I'm Agnieszka Soszynska. I'm a research associate at the University of Leicester, and I'm actually quite fresh here. I'm only half a year in the UK, and I come from Poland. My job focuses on analyzing satellite data. What this means is that satellites that are orbiting around us, they take images, and these images show different features. So there are satellites that image as your phones do. So you can see images like if you do in Google Maps or Apple or whatever provider. And there are images that are taken in different wavelengths, like what I do is thermal. What this means is that I see heat of the Earth. Basically, we can see the places which are hotter. My work focuses on the thermal imagery. Currently, I work more on the algorithms. So from these images, you can retrieve information based on physical properties. And this information can be used further on to basically help and support various applications of our everyday lives. One big thing is for support of agricultural production. Interestingly, plants get too little water, they get stressed. And when they get stressed, they show those signs earlier than you could go and see, okay, that plant is wilted. And in thermal imagery, you see that earlier. And our imagery can then support farmers, telling them, oh, you need to water that plant. So there's so many possible applications in thermal imagery that support sort of everyday life of people. One of the most direct things that I sort of collaborated on are the fire maps. So when I worked in Germany, I worked in a small satellite mission Firebird that was developed to monitor fires. So basically, you could see fires from space, and then you can derive maps to support firefighting. It's like space firefighting. And then you can see from those maps maybe where the fire can develop. And that is probably what touches the work of firefighters and people in the area. It's not very direct for every person on the street, but it can be sort of indirectly used. It sneaks into the lives when the farmers produce the food in that way, or if the fire is detected early. It's not direct. People don't see it, but it's there. One of the main objectives of the data sets that we produce is actually to monitor climate change. So since we see the heat of the Earth, we see obviously how it's changing, because we can see that in every single image we take, and there's lots and lots of imagery now. So it's easier to see those trends. And the data sets that we produce are explicitly ordered because of climate change monitoring. So you can see them in regional contexts. What's happening in the UK? What's happening in your city? What's happening in Leicester? And then a person who analyzes the imagery, the time series, it's what it's called if you have many images among time, the person can analyze that and say basically that UK is doing better or worse, or cities in those areas are doing better or worse. So, for instance, one of the main research area is urban heat. So if, say, Leicester is very built up in the city centre, that area will get really heated up in a heat wave, and then urban planners can sort of test mitigation strategies. Can they plant more trees? Can they maybe build their buildings in a different way? And all that can be supported by the imagery. So we can see that globally, obviously, with those IPCC reports that rely also on the data, and also in the very regional and local context too. I don't think there is a very typical one, also because I travel so much. So I go to conferences a lot, and then we present something, we have discussions. But if I were to describe a typical day at the office, it consists of all the typical office stuff, like meetings, with project partners, discussions. I write reports. The highlight of the day is the moment that you can really calculate something. So you what I do is code, so I program with Python. And this is the most fun part of it, because then you can really analyze things and then try to visualize them. This is one big important factor in our work. And then reporting, discussing, going back and forth to understand the process. Have we made the right interpretation or not? That is a big part. So it also sort of builds up all those little pieces, build up all the activities that I do. That is analyzing, discussing, interpreting, and reading all the time, learning on the way. What I do is basically sit by the desk and look at the imagery that is taken in space and then try to derive information from it. And there are people who take that information and derive further information again. So they will take that, for instance, the land surface temperature that we calculate, and they will say to farmers, oh, from that means that you need to put so and so much water, and that also belongs to that. And then there's engineering, there's people who understand cameras. You need to calibrate, you need to understand what the camera does. And then, yeah, obviously all the engineers around it to support a satellite. So there's so much to do. And we're in a moment where space industry is thriving. It will only get more. I always imagined myself traveling. And I did travel a lot, because basically that's the fourth country that I study, work, or live in. And science career allows that. And it's not like you have to do that. Obviously, you can stay in your birthplace and thrive there. But I was allowed to choose that career path because I was also traveling. I wanted to do so. So I think that is something that I knew from early childhood, that I want to understand the world. And that fascinated me from the beginning on. But it's not like it was a set career path. Absolutely not. I actually considered being a psychologist. I didn't know about remote sensing, because what I do is called remote sensing. I didn't know about it at school. And I had interest in traveling in the world, in nature, as a child. But then I thought, okay, studying geography sounds so fascinating, but then I can only be a teacher. And I couldn't be more wrong. So many things to do after studying geography. And then I sort of discovered step by step, by studying geography, by deepening the knowledge in the area, I got to know remote sensing, and it started to fascinate me more and more. And so I sort of navigated that direction, but it wasn't like a very conscious decision in my childhood. I know some people do that. I admire them, but I didn't. I think that only came around the studies, and it's such a shame. I mean, when I think about all the opportunities and the way geography is taught, oftentimes, I don't know the UK schools, but in Poland it was very traditional. Learn the map, learn the processes, and the processes can be learned through space, in space imagery. And that is so important to show that we can actually picture the whole space. And I mean, this amazing moment when the first image of the Earth was taken, right? And then people realize, oh, it's really, really round, and approximately round. And we can see that. We can see the atmosphere, so much information. So I didn't know that. And it's a shame. And I think a lot of people still don't know that. I mean, because everybody uses Google Maps or some other maps, whatever. And a lot of those maps are actually produced from the images that are taken from space. And people don't make that step about how is it made. People don't realize. So I really hope that will develop. I had a very traditional study cycle on geography with all the processes, on meteorology and physical geography and geomorphology, so how the Earth formed and what processes caused it. And then cartography and creating maps was one of them, and I really liked that one. That was a bit mathematical, to show the processes on the maps. And I think that sort of started my interest. And then remote sensing was one of the courses in my studies that started really early on. And I liked that from the very beginning. And it's quite amazing. It's been a little bit over 10 years since I started studying. And the field developed so much since. So there's so much more to show. But the idea of seeing how the world changes from image to image, you see the differences between fields and forests, and you can see if the forest is losing leaves. You can all see that, and that sort of fascinated me. But before that, I didn't really focus on or anything particular. I think I observed a lot of people and tried to learn from them. And on each stage, I had sort of a person that supported me. There were some people that inspired me too, that I could observe. And I had people that sort of took me by the hand and said, okay, let me introduce you to those people, they're important. And that really helped me. At each point, there is a set of choices that you make. And the place where I am, I made these decisions basing on the inspiration that I got. So many people, I think, and you can learn from everybody. Also in a negative way, but it's also okay. What do you want not to do? I think one message that I have for anybody in school is that it's your life to steer, to make choices. And I was always so afraid that I made the wrong choice. That it's not reversible, but it is. It is so much reversible. And after each school stage, I thought, okay, I could have made the choice and everything I learned and knew anyway, so it doesn't matter. So I think the main message, if I wanted to, if I could inspire people, I would say just decide for things, learn on the way, and have the courage to make those choices, learn from the mistakes. They're not about you, they're about learning. Things like that. Yeah, I think that would really help me when I was younger to feel a bit more secure. Because there are no wrong choices. You can still navigate around and go a different direction. I think there were many, many challenges, but probably the biggest one is a mindset shift. Because a lot of times, the way we are raised in school is sort of other people are right. And the biggest challenge is to make that mindset go away and have a mindset of, I need to check that. I need to understand that. And to really become a good scientist is to have that mindset. And I'm still learning, obviously. But I mean, currently we have tons of false information, of oversimplified information in the internet. And we need to be checking them, verifying them. And so this is a skill which is probably only becoming more and more important. But in science, it is critical because we will see lots of people trying to convince us about things, but we really need to verify and understand and to be able to make that process from the beginning to the end and understand it all the way. And yeah, probably this is the biggest challenge. It's really hard because space is so broad, and space industry is so broad. You can do anything between, as I mentioned, looking at the images, to building the satellites, to trying to become an astronaut. And I think the first thing to find out is what is fun for you. And then just take it on. And you can still change and adapt, but yeah, there's that. And have the courage to try. I didn't know maths well. I didn't know physics well because my school education focused on languages. And then I thought it would sort of not allow me to go further, but it did. I just needed to learn later, and it was possible. And a lot of people would think, okay, if you fail that exam, then it's gone, the opportunity is gone, but it's not. So you can learn after, you just have to be patient and learn.